Welcome to today's lecture on Introduction to Redux and Client-Server Communication, which is a part of Unit 5 of Advanced User Interface Technologies. In previous classes, we learned how React components manage data using state and properties. Those concepts work well for small applications. However, as applications become larger with many pages, many users, and many components, managing data becomes increasingly difficult. Imagine building an online shopping website. Different components need access to the same information such as user login details, shopping cart items, product information, wish list, order history, etc. Passing all this data from one component to another through properties becomes complicated. To solve this problem, developers use Redux, a popular state management library. In today's lecture, we will understand Redux fundamentals, Redux architecture, and how React applications communicate with servers using APIs. Learning objectives. By the end of this session, you will be able to understand Redux fundamentals, explain the Redux architecture, manage the application state using Redux, understand the client-server communication, perform API calls using Fetch and Axios, integrate Redux with asynchronous operations. These concepts are essential for building professional React applications. Introduction to Redux. What is Redux? First, let us understand what Redux actually is. Redux is a JavaScript library used for state management. But what is state? State simply means data that changes while the application is running. Some examples include current logged in user, shopping cart items, theme, whether that is dark or light, notifications, product list, student details, etc. Normally, React stores state inside individual components. However, when multiple components need the same information, Redux stores all shared data in one centralized store. Think of Redux as a central warehouse. Instead of every shop keeping its own products, all products are stored in one warehouse and every shop accesses the same warehouse. Advantages of the Redux includes predictable state management, easy debugging, better organization, simplified data sharing between the components. Now let's discuss some real-world examples. Let's imagine a university website. The student's name appears on dashboard, attendance page, marks page, as well as the profile page. Without Redux, each page would have to receive the student name separately. But with the help of the Redux, all pages access the same centralized data. Why Redux? Let's compare React applications with and without Redux. Without Redux, components pass data through many intermediate components. This is called props drilling. The application becomes difficult to maintain. Debugging takes more time. But with the Redux, data is stored centrally. Every component accesses the same data. It updates, becomes predictable. Applications become scalable. Let's think of a family. Instead of every family member calling each other for information, everyone checks the family WhatsApp group. Redux works in a similar way. Redux architecture. Redux architecture contains four major components. The components are store, action, reducer, dispatch. Now let's understand the complete flow. Suppose a user clicks the Add to Cart button. The step 1 follows. The component creates an action. Example, add item is given. Step 2, dispatch sends this action. Step 3, reducer receives the action. Reducer checks what should happen when add item is received. Step 4, reducer updates the store. Step 5, React automatically refreshes the screen. The shopping cart immediately displays the newly added item. Notice something is important. The user interface never changes the data directly. Everything passes through the Redux flow. This makes the applications consistent and easier to debug. Redux components. Now let's study each Redux component individually. The first component is store. The store is the heart of Redux. It contains the complete application state. There is usually only one store. The second component is action. An action is simply a JavaScript object. An example is given. The type here given is add item. Actions describe what happened, not how it is happened. The third component is reducer. A reducer is a JavaScript function. Its job is current state plus action that gives you the new state. Reducers never modify the original state. Instead, they create a new updated state. The fourth component is dispatch. Dispatch is the messenger. It sends actions to the reducer. Without dispatch, reducers never receive actions. Redux data flow. Redux actually follows a one-way data flow, unidirectional. The sequence is user event, dispatch action, reducer, store updated, React UI updated. Because data flows in only one direction, Redux applications are easier to understand. Developers always know where data comes from and where it goes. Redux Toolkit. Originally, Redux required a lot of code. Developers had to write actions, action types, reducers, store configuration. This created a lot of boilerplate code. Redux Toolkit solves this problem. It provides configure store, create slice, create ascent thunk. The benefits of using Redux: less code, easier setup, built-in best practices, faster development. So that is why today almost every modern React application uses Redux Toolkit. Client-server communication. Now let's discuss on client-server communication. The clients can be any of the following: browser, mobile app, React application. The server contains backend, database, APIs, application programming interfaces. Clients communicate with servers using HTTP requests. For example, a student logs into a portal, the browser sends login details to the server checks the database, it returns either login successful or invalid credentials. HTTP methods. There are 5 important HTTP methods. The GET method, which is used to retrieve information. The example for the GET method is to display all the students. Post method, which creates a new data. The example for the post method is student registration. The put method, which updates an entire record. The delete method, which removes all the data. The patch method, which updates only the selected files and fields. Students often confuse put method and patch method. Just remember, the put method replaces everything, but the patch method modifies only the required fields. Fetch and Axios. React communicates with servers mainly using Fetch APIs and Axios. Fetch is built into JavaScript. The example is given. It fetches the given link. Axios is an external library. Another example is given for the Axios. So the advantages of using Axios, it follows the simpler syntax, automatic JSON conversion, better error handling, request cancellation, timeout support. Both performs the same task, sending HTTP request, but Axios offers more convenience for large applications. Redux with API. Let's see the complete flow. Users opens the React page, then the component dispatches an action, then the Redux calls the API, then the server returns the data, then the reducer updates the store. Finally, the React automatically refreshes the user interface. This architecture separates business logic from user interface, making applications easier to maintain and test. Now, let's quickly revise the today's session. Today, we learned Redux is a centralized state management library. Store holds application data. Actions describe what happened. Reducers update state. Dispatch sends actions. Redux follows one-way data flow. Redux Toolkit simplifies Redux development. Client-server communication happens through HTTP requests. Fetch and Axios are used for API communication. Redux works seamlessly with APIs, application programming interfaces, to build scalable React applications. Thank you for watching this lecture. See you in the next lecture. Happy learning.